different types of modulation signals, different types of demodulation signals. First, we will send message signal as well as carrier signal. This message signal, whatever we will send, is superimposed with the carrier signal, and we will get output as a modulated signal. This modulated signal, again, we will process to get the original signal. That original signal is called as demodulated signal. Modulation and demodulation. First, here we have usefulness of modulation. Then we have amplitude modulation. Again, the different methods in amplitude modulation is linear modulation method, square law modulation method, and frequency modulation method. In second year practical examination, we have these practicals. In practicals, what we will learn? We will learn modulation, demodulation, and balance modulator, modulation of different signals. All these things is covered in modulations. Hello? 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 We will see different usefulness of modulation. Uh, where we are using these modulation techniques. Where we are using these modulation techniques. First, we will see definition of modulation. Two signals are combining together is forming a modulated signal. This modulation signal modulated signal document will say. Let's pen in this marker. We have two types of signals. The first signal, whatever is there, this is called as message signal. To this message signal, I am sending one signal. Another signal is here, carrier signal. Carrier signal is this, like this. First one is message signal. Second one is carrier signal. What is the difference between these two? In message signal, we have time period is more. Time period is more in message signal. In carrier signal, time period is less. If time period is less means here time period is more. What is the frequency? Frequency is lesser in message signal. In carrier signal, time period is less means we will use greater frequency in message signal. If the combination of these two signals will produce the output signal. How the output signal? The output signal is the combination of two, both modulated and demodulated. Both the combination, it will come the combination of two signals. Message signal time period is more, frequency is lesser. Whereas carrier signal time period is lesser and frequency is more. Based on this, now we will see further. Uh, Based on this, we will see further next one. In the next one, we will see. mm, Next here we will see the modulated and demodulated signal. In the introduction, one of the basic problem of communication system is we are sending from one to another over the channel. We are transmitting from transmitter to receiver. When we are transmitting from transmitter to receiver, we are processing with a single channel. If we are processing with a single channel, whatever we will get across the output, whether we are separating those output signals or not, that is called as a multiplexing here. Here, many individual signals are transmitted simultaneously over a single communication channel. But the multiple transmissions, whatever we are doing, is called as a multiplexing. And the individual message we are separating or not. The individual message is separated. The individual message is separated using the individual message is whatever the messages we got, we have to separate the individual messages. Those separating of individual messages, we will use filters. Those is called as frequency spectrums or frequency filters. The individual messages are separated using filters. The frequency multiplexing involves the use of auxiliary waveform. Usually, the carrier waveform is we are using. So, two signals we are processing. What are the first signal we are processing is called as message signal. The message signal time period is more and frequency is lesser. I will show this one in the whiteboard. Here, first one is message signal. This message signal time period is more. What about if the time period is more? Frequency is lesser. This signal is called as message signal. Another signal I have, that signal is called as carrier signal. This is carrier signal. The carrier signal time period is smaller. If carrier signal time period is smaller means frequency is more. When message signal, here I am using 1 kilohertz message signal. The message signal, whatever I am using is 1 kilohertz. The carrier signal, whatever I am applying here is a 1 megahertz frequency. 1 megahertz frequency. These two signals, if I join or overlap together, or combining these two signals, I will get the output signal. The output signal is like this. We will get message signal plus which signal, another signal we have? Carrier signal. So these two are superimposing each other and we will get amplitude modulated signal. In amplitude modulated signal, frequency and phase is constant. Just we are varying the amplitude of the signal. The varying of amplitude of the signal, the output, how we will get the amplitude modulation signal output. The signal output is like this. It will come like this. In this, we have waveform. See here, like this. In this, I'm getting peaks. In this, I'm getting peaks. This is called as a modulated wave. So here, which topic we are discussing? We are discussing about amplitude modulation. In amplitude modulation, amplitude is changing and phase and frequency is constant. In amplitude modulation, amplitude is changing and phase and frequency is constant. Here, this amplitude modulation is again three types: under modulation, over modulation, and uh, under perfect modulation. Here we are calculating what we are calculating. We are calculating modulation index. If it is equal to 1, modulation index is equal to 1. This is called as perfect modulation. If modulation index is greater than 1 or lesser than 1, like also we have. If the modulation index is less than 1, it is called as a under modulation. If the modulation index is greater than 1, that is called as a over modulation. Now we will see the images of three. First one, I am drawing the images of under modulation. Which modulation we are seeing now? We are seeing the image of under modulation. In under modulation, like we have waveform, sine waves on two sides, in the positive cycle and negative cycle. Inside we have our carrier signal. What is this signal? This is our carrier signal. This carrier signal is inside. We have the carrier signal is inside this one. This is which modulation? This is under modulation. In under modulation, modulation index is less than 1, which we will do again this one in the practical session also. In this modulation index is less than 1. So whatever the diagram we saw, first diagram is which one? Under modulation. Next, we have perfect modulation. Perfect modulation means we will get output in diamond shape. The difference between these two is, I will show like this is there. It's not that much perfect. Mm. Mhm. There is no gap in this. Again, even in this, we have waves. Even we have in this waves. Like this, we have waves. Next, this is called as perfect modulation. How you are saying perfect modulation? There is no gap. See the previous one? There is some gap between the, here, see this gap? Here you have this end, here you have this end. This gap is more. Whereas in the second one, no gap between the two edges. It is almost looking like zero index touching together. Two diamond shapes are touching together. This is called as a perfect modulation. In perfect modulation, we have modulation index as 1. In perfect modulation, we have modulation index as 1. Mm. In over modulation, next we have diagram of over modulation. In this, modulation index is equals to 1. Modulation index is equal to 1. Next one, what we have? Next one is over modulation. Now the next diagram is over modulation. Small, not a bigger gap. If we have bigger gap, that is under modulation. If exactly two diamonds are touching together, that is considered a perfect modulation, where modulation is 100%. Next, we have over modulation. Over modulation is greater than 100% or greater than. How the diagram? Like we have diamond shape, small line, like we have not touching, small gap is there. This is which diagram? Over modulation diagram. Here, x-axis, I am taking time period. In y-axis, I am taking amplitude. Variation of the amplitude. Amplitude is varying. Again, in this, we have what? carrier signals. The top section is modulated signal. Here we have carrier signal. So this is about amplitude modulation figures. Again, in the output waveform, in one more two diagrams is there. Next diagram is, first, how is your message signal? Message signal means sine wave. Message signal is sine wave. Next signal is which one? Carrier wave. In carrier wave, we have smaller time period. Carrier wave is smaller time period. These two are overlapping together. If these two are overlapping together, we will get what? Modulated signal. How the modulated signal? The modulated signal is outside we have sine waves. Outside we have sine waves. In this outside sine waves, we have carrier signal. We have carrier signal. Like this. This is the modulation, amplitude modulation. Based on this, now we will follow our topic. Features. Draw. This, Uh, Today our topic is modulation. After seeing the introduction, in modulation, what are the topics we have? In modulation, we have first one is usefulness of modulation. Next one we have amplitude modulation. Again, amplitude modulation, we have three types. First one is linear modulation method, transistor collector modulation, square law modulation method. Next, we have frequency modulation. Again, in the frequency modulation, we have derivation of frequency modulation. Again, we have reactance tube method, transistor reactance method. Next, we have in the syllabus comparison of amplitude modulation and frequency modulation. So in the exam point of view, you learn amplitude modulation and types of modulation, definition of frequency modulation, and let's see the comparison of both frequency and amplitude modulation. Now we will see the first one. What is the usefulness of first? What is the introduction is given? So in this chapter, both are explained. What are the both the things? One is amplitude modulation, another one is frequency modulation. And different types of modulations is also explained. Now we will see the first introduction part. In introduction part, what is given here? Both we are transmitting messages simultaneously over a single channel, which is here mentioned in which line? We are transmitting simultaneously signals on a single channel. Whatever transmitted, again, we have to collect those across the output. So whatever we are receiving across the output having different frequency spectrums. So we have to separate the messages whatever we are received. Thus, for that we are using the technique called as frequency multiplexing technique is used for separating the signals. Again, in this modulation type, we have three types. First one is amplitude modulation, frequency modulation, and phase modulation. For this, I'm using two types of signal. One signal is message signal, another signal is carrier signal. Next, we will see the usefulness of modulation. What are the uses we have using this modulation? You can expect this as a usefulness of modulation. We can expect this as a 5 marks short question from this. How marks? 5 marks. Short question. We can expect this usefulness of modulation. In this, what are the subheadings we have? First, we have the suffix. What is the first subheading? First subheading is frequency multiplexing. Second subheading is practicability of antenna. Third one is narrow banding. Fourth one is common processing. So explain these four terminology. Terminology, then you will get 5 marks. What are the first one is frequency modulation. In the frequency modulation is what we are sending the signals. All the signals are sent with single communication channel. One side I have transmitter. Suppose imagine I have transmitter at one side. Mm, Transmitter at one side and other side receiver. I'm sending signals from transmitter to receiver. The sending of signals from transmitter to receiver, I'm sending with the different frequencies. Whatever the signal we are received across the output, we have to separate the frequency. Suppose first signal, whatever I received, the frequency ranges from F1 dash to F2 dash. Suppose second set of frequencies I am receiving. The frequencies is in the ratio of F1 dash to F1 double dash to F2 double dash. So different frequencies we are getting. All those, whatever is multiplexed from input to output, all those things has to be demultiplexed. So next subheading is practicability of the antenna. What are the things covered in practicability of antenna? In the free space, what happens? Using antennas, we are sending signals as well as receiving the signals. Here, while sending and receiving the signals, the length is not the matter. We can send these signals from across the longer distances. Suppose we have a signal of 1 kilohertz signal. This 1 kilohertz signal is transmitted with the wavelength of 33 lakh meters, which is impracticable of length. What is the meaning of? Whatever is the distance between the two signals, we can transmit easily. Whatever is the distance between the two signals, we can transmit easily. Next one, we will see about the narrow banding. What is the meaning of narrow banding? Suppose I'm using signals. Whatever the signal I'm using, it has a higher bandwidth. If it has higher bandwidth, means it will not move properly. Whatever the output we will get, it will not show proper output if the bandwidth is more. So for that, we will prefer the bandwidth, whichever is smaller bandwidth only good for signal processing instead of longer bandwidth. Next one more, what we have common processing. So the same process we have to use for the, whatever the process we used for the input, same method of process we have to use for the output. So method of process is same for input side and as well as output side. This is called as common processing. So how many subheadings we have for the usefulness of modulation? In usefulness of modulation, we are using 4 separate subheadings. First one is frequency modulation. In frequency modulation, whatever the input signal we are sending, it is coming to the output. Across the output, what happens, the signal strength, it will get a different spectrums. We will get the output of the signal having different spectrums. So whatever the signal we will get, the same thing has to process across the output without any distortion and disturbances. Is called as the frequency multiplexing. uh, Next subheading, what we discuss next subheading. Yes, we got older version. After frequency multiplexing, we discussed about practicability of antenna. In practicability of antenna, is distance is not the matter. We can transfer the signals from input to output without bothering of the distance. Without bothering of the distance means, suppose my signal frequency is 1 kilohertz. I am sending with a wavelength of 3 lakh meters. So here impracticable of length means we are not bothering about the length. We can transmit signals from one place to another place with high frequency, with higher frequency. Next one, what we have next one? Next one is narrow banding. What is the meaning of here narrow banding? The bandwidth has to be very narrow instead of wide bandwidth. Before discussing this, what is the meaning of bandwidth and what is the meaning of narrow bandwidth and wide bandwidth? Which one is better? Sending signals with narrow bandwidth and sending signals with wide bandwidth. What is these two meaning? Narrow bandwidth means here we are using limited range of frequencies are used for processing and communication, whereas bandwidth means remaining all frequencies are allowed. Suppose I will tell example of narrow bandwidth. In narrow bandwidth, the processing of signal is this here. So here how many is possible? Signal lines is possible. This one. Only limited frequencies are allowed in the narrow bandwidth. Wide bandwidth, and wide bandwidth is this one. So better to use narrow bandwidth. Next is common processing. In common processing means transmitter side, whatever the methods we are following for transmission, same type of methods has to follow for the receiving section also. So this is the usefulness of the modulation. Next topic we have amplitude modulation. So in the amplitude modulation, this is the diagram of amplitude modulation. What this diagram represents? What this diagram represents? The first line, this already discussed a little bit introduction about this one. This is message signal. Next signal, whatever we have, which signal? Carrier signal. These two are superimposing with each other. If these two are superimposed with each other, what we will get? Like this we will get. If these two are superimposed, outer lines is called as a modulated wave, inner line is called as a carrier wave. So it is a is this under modulation, over modulation, or perfect modulation? It is under modulation. Why you are saying under modulation? Modulation index gap is more from top to bottom. So this is called as under modulated signal. Now we will see the derivation part of this under modulation signal. What is the point is written here? First, we will see the theory of amplitude modulation. Then we will discuss the derivation part. In the amplitude modulation, the amplitude of the carrier signal is varied by the modulating the voltage and keeping the frequency and phase is constant. In amplitude modulation, which is constant? In amplitude modulation, frequency and phase is constant. Which one we are varying? We are varying here. Carrier signal is varied with respect to the modulating voltage. Variation is which one? Carrier signal is modulated with respect to the modulating voltage by keeping frequency and force both are constant here. Here we are using large frequency of the carrier wave. Example, message signal I am using 1 kilohertz. Message signal is 1 kilohertz. What is the carrier signal? 1 megahertz. So carrier signal frequency is more. Here I am taking the equation. What is this equation? This is the equation for the carrier signal and message signal. We have two equations. First equation is carrier signal equation. Next equation is message signal equation. And what is carrier signal equation? We are using VC equal to VC of cos omega C T plus theta. As well as I'm using message signal also. I'm using theta for the carrier signal because we are varying the carry, whereas with respect to the message. Next, we have message signal. What is message signal here? Here the message signal is Vm equal to Vm cos omega t. Message signal is Vm equal to Vm cos omega t. I'm superimposing these two, means I'm adding these two and writing one resulting modulated wave. The resulting modulating voltage, what we are getting, V equal to, I will write this on the whiteboard. Then we will see in this. What is carrier signal? We have carrier signal Vc equal to capital Vc cos omega t plus theta. Why I am theta taking is the variation is with respect to the carrier signal. Next voltage I am taking. What is the next voltage? Modulated wave. Modulated voltage. What is modulated voltage? Vm equal to capital Vm cos of omega mt, modulated signal. Whereas previous one is carrier signal. By these two, I am getting the resultant modulated wave. The resultant modulated wave is represented with V. V is equal to Vc plus Vm. Before writing Vm, I will take a constant. Afterwards, I will take Vc plus Ka times of Vm. Ka times of Vm of cos m omega t plus omega ct we will get. Vc plus Ka Vm type of cos omega mt into cos omega ct. Cos m omega t plus cos omega ct we will get. After this, what I am writing here, I am dividing with Vc. Take Vc common and division. Here I am taking Vc common. Here I will get 1 plus if I make common, we have Vka Vm by Vc times of cos omega mt plus bracket of cos omega ct we will get of cos omega ct. What we got? This is the equation for velocity. This is the equation for velocity. Next, Ka Vm by Vc, I am talking modulation index for the amplitude modulation. So that one I am representing with what here? Here I am writing Vc plus 1 plus modulation index for A means amplitude modulation, Ma times of cos omega mt times of cos of omega ct. This is the resultant modulated wave. What is the value of Ma here? Where Ma is equals to Ka Vm, modulated voltage by carrier voltage Vc. This is modulation index. Using this, here in the above equation, I have one term called cos C, cos D. These two terms. Cos m omega t, cos omega ct. Cos C plus cos D. We have one formula. 1 by 2 cos omega c plus c by 2 cos omega c minus d by 2. We will see that one further. Continuation. Next, we have one formula. What is the formula? Cos C plus cos D. Again, I will show this one in this PPT. What is the formula for cos C plus cos D? Cos C plus cos D formula is 1 by 2 times of cos C plus D plus cos of C minus D. That is applied here. Cos C plus D by 1 by 2 times of cos C plus D, cos C minus D by 2. This formula I am substituting in place of this one. Cos C plus 1 by 2 times of cos C plus D plus cos C minus D. After substituting this, we will get one equation. What is the equation we will get? Modulated voltage V. Modulated voltage V equal to Vc cos. I will show this one directly in the screen. Already in the textbook that is written. What is the final equation after applying cos C plus cos D? We will get equation 13.6. See here, cos C cos D. This is which term? Cos C cos D. What is the formula? Cos C plus D. See here, omega C plus omega M. Cos C plus D. Here we are getting cos C minus D. 1 by 2. The 2 denominator is we are taking. So this is the final equation of the amplitude modulated wave signal. This is the final equation of which one? Amplitude modulated wave signal. What is the formula? V equal to Vc times of cos omega c times of t plus MA modulation index of Vc by 2. One time you are taking cos omega c plus omega m. Another time you are taking cos omega c minus omega m. Here total you have three types of frequencies. One frequency whatever you have is omega c. Another frequencies whatever you have is omega c plus omega m. Another whatever you have is omega c minus omega m. Now this one is side bands. These two is called as side bands. The omega c is the central band, which is given in the next slide. Here we have three types of frequencies. And what are the first frequency we have? Omega c plus omega m. Another frequency is called omega c minus omega m. That one, finally we are getting frequency spectrum of the modulated wave. With the one frequency we are getting omega c, another frequency is omega c plus omega m, and the third term is omega c minus omega m. Based on this, we have a graph. See here. MA means modulation index here. A means amplitude, modulated of the amplitude, modulation index of the amplitude with the carrier signal. What is here? This is carrier signal. This carrier signal is represented with omega c. This carrier signal is represented with omega c. And another side I have omega c plus omega m. Another side I have omega c minus omega m. So if omega c plus omega m, there is a printing mistake in the textbook. This is omega c plus omega m. This is plus symbol between omega c plus omega m. This is a plus symbol we will call as a upper side band. Other side we have minus symbol. The minus symbol is called as a lower side band. This is the frequency of the modulated signal, message, input signal frequency. What is this one? Input signal frequency. So total we have amplitude version frequency graph. In amplitude version frequency graph, how we are representing the graph. How we are representing the graph. Here graph is like this. Pencil. 10. Okay. Graph is like this. In this first side, I have modulator signal, WM. What is WM? Frequency of the modulation wave. Next, I have carrier wave. This carrier wave is represented with what? Omega c. To this carrier wave, I have two side bands. One side band is called omega c plus omega m. Other side band is omega c minus omega m. Whatever plus sign I am taking, this is called as upper band. Whatever the minus sign, I am taking that as a lower band. Omega plus c, omega c plus omega m is called as upper side band. What is another band? Omega c minus omega m. That is called as lower side band. This upper side band and lower side band. These two bands is coming across which band? Carrier frequency. Two sides where we are getting for the carrier frequency. But first side lo max in the beginning only we have message signal. So this is about amplitude modulation. Next, the different types of amplitude modulations we will see. The different types of amplitude modulation we have. First one is linear modulation method. Linear modulation method, rough diagram we will see. Next, we will go for the explanation. In the linear modulation signal, what is the diagram we have? Here we have class C amplifier. This class C amplifier, we are connecting this one to the DC supply voltage. See the diagram in the figure number 117, how the diagram is. Here we have plate modulator class C amplifier. We have modulated plate like this. This is modulated plate. To this, one capacitor is connected. Across this, what is connected? Another one, class C amplifier. What is class C amplifier? Is the combination of one capacitor as well as one inductor. Like this is across the output side. So I'm calling this as a load circuit. Always remember, across the output, we will call it as either load resistor or load circuit, whatever it is in the across the output side. Next, like this connection you have. Here one more again you have inductor. To this, here I am taking transformer connection. This from here I am sending modulated signal. To this modulated signal, DC supply is applied with minus and plus sign. This DC supply again I am connected to the positive supply plus minus. From here it is connected to source. From this source it is connected here. This is a rough draft. Whatever the supply, a small correction in this. Here to here connection. This. Like take here minus plus sign. Minus sign, plus sign with power supply voltage, plus sign minus. With power supply voltage, plus sign minus. This is modulated plate. To this modulated plate, from here I am sending message signal. Message signal is here you have one transformer. Using this transformer, which signal I am sending? Message signal is sent from the transformer. Again, here we have one capacitor and inductor combination. This works as a load with the modulated plate. And again, I am applying the supply. After giving this diagram, which type of output we will get? Now we will see the type of output what we will get. Finally, just remember the amplitude modulation output is always modulated signal. Modulated signal meaning here you have message signal. This side is another message signal. In between these two message signals, in middle what we have? Carrier signal. This type of output is needed. This output is needed. For this type of output, what are the inputs we have? For this type of output, we will see the inputs. One signal is carrier signal, another signal is input signal. Two we will apply to this one. So to get this output, I have to apply two input signal. What are the input signal for this one? One is taking like this. Another one I am taking like this. This is input. So treat this as a message. Treat this as a message. And across the same axis, treat this as a carrier signal. Like this, you have two types of inputs. To this, to You will get output. Output is modulating signal. So here another diagram. This is supply voltage VBB with current I with one single line. To this, what is the value across this? What is the value across this? What is the value across this? Perpendicular lines is drawn for these three. In these perpendicular lines, I am taking one sine wave. I am taking one sine wave. So, for this, here also either will show. This is your input of the wave. This is your input of the wave. For this input of the wave, the output is what? Modulated signal. We have three lines. In this, we will get modulated signal. In this, we'll get carrier signal. So, getting this carrier signal is called as modulated wave. This is the output of the modulated signal. Across the input side, what are the things we are using? This is one of the class C amplifier. In the description, what are the things we have to write is, this is one of the class C amplifier. How you are saying this is one of the class C amplifier? One capacitor and inductor is connected here. See, this combination, one capacitor and inductor is connected. As one capacitor and inductor is connected, we are treating this as a class C amplifier. Here I am connecting message signal. These two signals are superimposed each other, and output we are getting the desired modulation output is given. Here modulation signal is connected in series with the direct plate supply voltage VBB. What is modulation signal? Here is this one. This modulation signal is here is MS1. This modulation signal is connected in series. This is series combination. I will change the color. See here, this is the modulation signal. This modulation signal, color is not visible. This is modulation signal. This modulation signal is connected in series. This modulation signal is connected with the series with the supply voltage. What is the name of the supply voltage here we are using is VBB, is connected in supply voltage VBB. After this, the total output, whatever we are getting is shown in the graph. For this one, we have derivation part. Again, same derivation part. Just I will give the hint and you complete this derivation part. Still some, we have a lot to discuss. Share. Same derivation as previous derivation. See here, what is the diagram? See, this is the diagram. In this diagram, this is message signal. Message signal is in series with VBB. And to the plate here, class C amplifier is connected and we are getting final output. See this image. What is this graph? This graph is represents DC supply voltage. DC supply voltage as well as message signal RMS value. The DC supply voltage with message signal RMS value. Actually, even it is DC supply voltage, always message signal is also sine wave. మనకి ఇక్కడ message signal sine wave ఉంటుంది. Carrier signal is also sine wave. Both are superimposed each other and we got final output. This is the waveform of the modulated class C amplifier. Next derivation part. Derivation part means take two voltages and write common voltage. What are the two voltage? VG equal to VGM across the grid. Means across the grid means across the carrier wave anamata. Next VGM equal VC. Here carrier, this is modulated. Both are joined together. Again, we are calculating modulation index. Again, we are calculating. Just go through this one. Next one is we have. What is the next one? Next one is transistor collector modulation. Here, transistor collector modulation. Which is transistor in this? This is the transistor part. Which is base, which is emitter, which is collector. This is base. This terminal is emitter. This terminal is collector. So, across the collector of the, just I will draw a rough diagram here. We have like this. This is collector. This one is base. This one is emitter. Across the collector, I am taking one modulated signal. Which signal? Modulated signal. Across the base, which signal I am taking? Across the base, I am taking carrier signal. So two signals are taken. One signal is across the base, another signal is across the collector, and across the emitter, I am taking one resistor as well as capacitor. These two are combined and connected to ground. These two are combined and connected to ground. Then where we are taking output? We are taking output across the beside modulated signal. Beside modulated signal, I am taking collector. Here, what you have down, I will write here. Two capacitors is there. Filter circuit. This is called as a filter circuit. Two capacitor with one inductor combination. Across here, I am taking my output. Across this, I am taking my output. For that, this is called as, the name is called as what? Transistor collector modulation. To the transistor collector side, I'm connecting modulated signal. Across the base, I'm connecting carrier signal. Across the emitter, one resistor and capacitor is connected together and connected to the ground. Beside the modulated signal, I'm taking the filter combination. Across the filter combination, output is collected. Now we will see this one, where we will use this one. This is useful for low power levels. What is the introduction is given for this topic? Transistor radio frequency amplifier can be employed for the purpose of modulation. And this is similar to the vacuum tube circuits. And this is used for low power levels, means we need lower power. So especially this transistor modulation is used for power applications. See here, modulation signal is fed to any of the three elements. So, this topic lo where the modulated signal is connected, whether modulated signal is connected to collector, modulated signal is connected to base, or modulated signal is connected to emitter. Here, the modulated signal is connected to across the collector. That is mentioned here. We have three elements. What is the meaning of three elements? The three elements meaning, the three elements ante either it is emitter, base, collector. Out of three elements, I have connected my modulated signal to collector. For that, we are calling this as a collector modulation. It has many advantages over compared to other modulations. What are the modulations? What are the advantages we have compared to other modulations? The advantages are it has linearity, high efficiency, and high power output for the transistor. These are the advantages of using transistor collector modulation. What are the advantages? Good linearity and collector efficiency is good. And we have high power output per the transistor. These three are the advantages of using transistor collector modulation. After this, what we have a derivation part. In the derivation part, what is given here? In the collector modulation, modulated signal is applied to the collector. We are collected, modulation signal is connected to the collector. To this one, a DC power supply is connected series. To this one, DC power voltage is connected. Next, the output stage of the modulating amplifier, the collector load across the radio frequency amplifier means here we are connecting filter circuit and I am getting 100% of modulation. Next, what is VMM? Voltage across the modulation maximum value. Here to obtain the 100% modulation, maximum modulation, VMM is maximum modulation is equal to the voltage across the collector. Voltage across the collector. So this is possible only for the positive off cycle. In general, we have positive off cycle as well as negative off cycle. So the condition, what is the condition? V collector voltage is equal to modulated voltage maximum. So this is possible only for which one? Positive off cycle. To the positive off cycle, I am taking Vm equal to here. We have positive off cycle as well as negative off cycle. For the positive off cycle, modulated voltage, maximum modulated voltage is equals to maximum collector voltage, as well as the current across the modulation is equal to the current across the collector. We have 3 equations. The first equation is voltage across the modulated one, maximum modulated voltage equal to collector voltage. Next one, current across the modulated current equal to collector current. Based on this, I am calculating power. Power P formula is what? Power P formula equal to Vm Im by 2. Power formula equal to Vm Im by 2. We can also write as, because both are equal, VCC collector current, collector voltage by 2, which is equal to 1 by 2 times of the power across the supply, power across supply. Using this, we have to calculate the load value. Using this, calculate the load resistor value. RL equal to Vm by Im. Also, we can call as VCC by IC. Just we will see the overview of the topic again. What is the overview of the topic we discussed? What is our topic name? Topic name is transistor collector modulation. In transistor collector modulation, I am using collector. Across this collector, we have message signal or modulated message signal. Across the base, I am using carrier signal. Across the base, I am carrier signal. Across the emitter, I am connected one resistor as well as capacitor. These two are connected ground. Where we are collecting output? We are collecting output across the message signal using filter circuit. Which circuit? Filter circuit. How the filter circuit? We have one capacitor, here one inductor, another capacitor. Here I am taking output. Why we are calling collector means message signal is connected across the collector. This is collector, this is base, this is emitter. Message signal and output is all these things is connected through which one? Collector. So I am calling this as a collector transistor circuit. After this, what are the things has to include? After the diagram, just give the description, advantages. After that, again, we have positive cycle and negative cycle. We will get only voltage, current, and power. Everything is for positive cycle only we are writing. Also modulated voltage, VM equal to collector voltage, VCC. Modulated current, IM equal to current is ICC. Next, write power formula. Next, what is power formula? Power formula equal to P naught, which is in all this topic is in the page number 120. Power formula P naught equal to VM IM by 2. Also, we can write VC ICC by 2. So, 1 by 2 of the power supply total power supplied. Also, we can write resistor value. What is resistor? RL equal to VM by IM, which is equal to VCC by IC. So this is the topic of collector current. Next topic we have. What is the next topic? So 3 types I said. What are the 3 types I said? First one is linear modulation method. First one we discussed linear series modulation. Second one we discussed transistor collector modulation. Third one we have, what is the third one? Square law modulation method. This is also one of the important topic. What is our topic? Square law modulation method. Another important topic is square law modulation methods. We will see first diagram in this one. How the square law modulation method. Here 2 transistors are used. Has to practice for the examination. Practice is very important, or else difficult to score all these diagrams and drawing in the exam and getting marks. See here, in between, here, shortcut diagram, again I will show you. Here, 2 transistors. What is this one? Collector, base, emitter. This transistor is collector, base, emitter. The 2 transistors. One is emitter is connected to collector. This combination I am connecting to where? Carrier signal. This is connected to carrier signal. This carrier signal, other part I connected using transformer. Other part what we have? Transformer. From transformer, the middle connection is there. From this transformer, actually this is not neat, okay. Modulated signal. This modulated signal is connected with transformer. Modulated signal is connected with transformer. Other side of the transformer is 2 sides is connected to transistor. 2 sides is connected with transistor. Again, these 2 is connected with 2. Connected to output. Another transformer. This another transformer is for output purpose. Here, the middle is connected with carrier signal. This is a rough diagram we have. This is collector, base, emitter. This is collector, base, emitter. Another clear diagram or rough diagram. How to remember for the exam? 2 transistors. How to remember for the exam? 2 transistors we have. These 2 is connected with carrier signal. The other 2 points is connected with message signal. Shortcut diagram. Wrong, 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 wrong. Mm. Message signal is connected to base. This one is also connected with base. Mm. And again, this one is connected with inductor. So what you understood from this diagram? Message signal is connected to base. Message signal is connected to base. This no gap here means actually here you have transformer. Transformer, primary wind, secondary wind. Secondary wind is connected to carrier signal. Primary wind is connected to base. This is the diagram draft we have in the textbook. Other side, this one is connected with the power supply, negative power supply with positive power supply, and connected to ground. Here, what the things we have to consider? This is Q1 transistor. This is Q2 transistor. Whatever the voltage we have across the Q1 transistor, I am taking this as voltage as VB1. Whatever the across the voltage across to Q2 transistor, this is I am taking as VB2. This is I am taking as VB1. This is carrier signal. This is message signal. This is the diagram we have. This is also called as a balance modulator. Which one we are discussing? The topic of this one is in the page number 120. 120 page in the material. And what is the name of the diagram? The diagram name is balance modulator. And what is the name of the topic? Topic name is square law modulation. What is topic name? SQUARE. Square law modulation. This one you will chance of getting in the examination. Square law modulation. After drawing this diagram, again we have derivation part. Again in the derivation, we will get final, I will write final equation. We will see in the slides. In the derivation, finally, again I am getting omega c plus omega m I am getting. Another one I am getting omega c minus omega m I am getting. And another carrier frequency I am getting. Whatever omega c plus omega m, this is called as upper side band. This is called as upper side band. This is called as lower side band. This is called as a middle band. Now we will see the derivation part of this one. Then we will complete amplitude modulation. In the textbook part, we will see this one. The topic, whatever we are discussing, is square modulation method. What is the square law modulation method? The balance modulator is also called as a square law modulation. Here, this method is useful for the relation between the amplitude of the signal and depth of the modulation. So, here we are considering two parts, two terms. What are the two terms? One is amplitude modulation we are concentrating. Another we are concentrating depth, how much depth it is, the depth of the modulation. Using these two terms, I am calling it as a square law. Which law? Square law. These two combination is called as a square law. And just rough diagram I already drawn. And now we will see the overview of the diagram. Now what is the diagram? Here the two transistors. Which is two transistor? Transistor. This is one transistor. Again, this is another transistor. This is emitter. This is emitter. The two emitters are connected to output transformer. The two emitters are connected where? Output of the transformer. And next, the two bases. See, the two bases are connected to where? Transformer. The two bases are again connected to transformer. This transformer is called as modulating signal. Next, see here, This is emitter, this is base, which is emitter, this is emitter, sorry. This is collector. The collector. The collector and emitter is joined together using what? Carrier signal. The emitter and connector, both are connected using carrier signal. Now we will see the derivation part. Here we have two voltages, base 1, base 2 voltage. And which is base 1 voltage and which is base 2 voltage in the diagram? Here, VB1 is from here to here is VB1. From here to here is VB2. That is VB1. This is VB2. We will see two voltages. VB1 equal to modulation plus carrier. Second modulation means why I am calling as M1 and M2. Here we are taking two transistors. So across the transistor I am representing with M1. Across the second transistor I am representing with M2. And now see the derivation part. What we have? Vm1 plus Vc. What is Vc? Vc cos omega t. What is Vm1? Vm cos omega t. And next Vb2 equal to Vm2 plus Vc. Here I am taking minus. Why I am taking minus is the two transistors, across the two transistors, whatever the modulated voltage we have, that modulated voltage is appearing 180 degrees out of phase. This is very, very important point. As we have two transistors. ఇట్లుంది కదా, ఒక ట్రాన్సిస్టర్ ఇక్కడ ఉంది, ఇంకో ట్రాన్సిస్టర్ ఇక్కడ ఉంది. ఈ రెండు కనెక్ట్ చేసినాం. ఈ రెండు నుంచి మాడ్యులేషన్ సిగ్నల్స్ ఇచ్చాము. No, I think. Here, two transistors. Across the two transistors, through two transistors, whatever we are getting output, that output is 180 degrees out of phase. For that, I am taking base 2 voltages in terms of minus. Modulated voltage is minus. Whereas the first modulated voltage, Vm, I wrote here Vm1, here minus Vm1 plus Vc. What is Vm? Vm equal Vm cos omega t. In place of plus, I kept minus. Based on it, I am calculating current. What is the current formula here? Write these steps in the whiteboard instead of discussing. We will see the derivation part. First, what is VB1? First, VB1, voltage across the base 1 equal to Vm1 plus Vc. What is Vm1? Vm1 equal to Vm cos omega mt plus Vc cos omega ct. We wrote these two. Next, another base voltage, we have VB2. This is page number 121. Refer page number 121. Next, voltage across base 2 is equals to voltage of modulation Vm2 plus Vc. As it is 180 degrees out of voltage, I am writing minus of Vm2 plus Vc. Minus of Vm2 plus Vc. Minus of Vm2 means minus of Vm cos omega m t plus Vc cos omega ct. This is equation for minus VB2. VB2 equal. This is the equation for VB2. Then we have current equation. What is current equation? Current equation across the collector 1 is equals to addition of these two. Formula we have. Just I will write the formulas. A1 VB1 plus A2 VB1 square. Same way we have formula for collector current to IC2 is equals to another formula A1 VB1 plus A2 VB2 whole square. Substitute and simplify it. After simplification, we will get final output. What is the final output we will get after simplification? V naught equal to K times of, K is a constant, K times of 4 A2 VM VC cos, continuation, cos omega m times of t cos of omega c times of t. We will get final equation, this one. Now, this one again, cos, this one I am taking as a cos c, this one I am taking as a cos d. And final substitution, we will get equation. What equation we will get? V naught is equal to 2 Ka2 Vm Vc times of cos omega c plus omega m times of t plus cos omega c minus omega m times of t. Again, this is upper band, this is lower band. This is about which one we discussed? This is about square law modulation method. After discussing square law modulation method, next one we have frequency modulation. Just I will explain the concept of frequency modulation. Frequency modulation. Again, we have modulated signal. This is modulated signal. Next signal, what we have? Carrier signal. What is carrier signal? This is carrier signal. After carrier signal, we have to get modulated wave. How to represent modulated wave? Frequency modulation means actually we have output. కొంచెం నియరెస్ట్ ఉంటుంది frequency. Next ఇలా ఉంటుంది. Means not of same size. Not of same size. I will show this one. Images I will show. Modulated signal. All waveforms I will show you. Modulated frequency signals, amplitude modulation signals, as well as phase modulation signals, frequency modulation signals, how it will looks. See, this is the image of frequency modulation. What is the input? What is the output? And how it is differing? See this image. This is the image of frequency modulation. This is message signal. This is carrier signal. But how output is looking? Frequency is changing here. In the output, frequency is changing. How you are saying that frequency is changing? See here, for this one, so in this wave, just observe this output waveform, third one. Here, time period is more. Across my cursor, just observe the cursor point. Here, the time period is more. If the time period is more, means frequency is lesser. Ikkada chudandi. In the beginning, very close. Here means time period is less, frequency. So frequency of the signal is varying. If the frequency of the signal is varying, we will call it as the frequency modulation. Next, I will show amplitude modulation, three types. I said amplitude modulation. Modulation signals is of three types: over modulation, under modulation. See this waveform, it is more clearly explained here. What is amplitude modulation? How the signal changes? Just this is a message signal, modulated signal. I want over under modulation, over modulation. The signals I will show you. Where is under modulation, over modulation? Three types of modulations. This observe this. Just observe this figure. In this, which is under modulation, which is over modulation, which is perfect modulation. Observe this image. The first figure. The first figure is, there is a gap. See here from 0.5 to minus 0.5, there is a gap. 0.5 to minus 0.5, there is a gap. So here the modulation is 50% of modulation. This 50% of modulation I can also call as under modulation. If you calculate modulation index, you will get less than 1 or less than 100%. We will call this as a under modulation. And observe the second diagram, 100% modulation. In 100% modulation, almost overlapping across the zero. Just observe. ఇక్కడ ఓవర్లాప్ అవుతుంది, జీరో దగ్గర ఓవర్లాప్ అవ్వాలి, కానీ 1.5 నుంచి 0.5 దగ్గర వచ్చి స్టాప్ అయింది. ఇక్కడ కూడా చూడండి 1.5 నుంచి -0.5 దగ్గర వచ్చి ఆగిపోయింది. దెర్ ఇస్ అ గ్యాప్. కానీ ఇక్కడ సెకండ్ ఇమేజ్ లో ఏముంది, జీరో ఉంది. జీరో దగ్గర రెండు ఓవర్లాప్ అయిపోతున్నాయి యాంప్లిట్యూడ్స్ ఫర్ ద పాజిటివ్ హాఫ్ సైకిల్ and for the negative half cycle. So here modulation is index is equal to 1. And next, see the third image. In the third image, greater than 1. Why it is greater than 1? ఇక్కడ మనకి టచ్ అయినప్పుడు స్లీపింగ్ లైన్ లాగా ఫామ్ అవుతుంది. బట్ దెర్ ఇస్ ఎ స్మాల్ గ్యాప్. 1, 2, 3, 4. Even you are getting smaller waves across 0 to 0.5, 0 to -0.5 దగ్గర మనకు స్మాల్ వేవ్ ఫార్మ్స్ ఫామ్ అవుతుంది. సో దిస్ ఇస్ కాల్డ్ as which one? Over modulation. And next, frequency modulation. Again, we have different types. Now, what are the different types of frequency modulation? Just we will see the list. Different types of frequency modulation, sir. Reactance tube method, first one. Second one is, first one is reactance tube method. Is only one method. First in the textbook, derivation part is given. After the derivation part, only one method is mentioned, that is reactance tube method. Reactance tube modulation is mentioned in our syllabus. Next one is reactance transistor reactor modulators. Two methods is mentioned in our syllabus. We'll see the methods and advantages, disadvantages. We will see. What are the after this? Which one we are discussing? I shown what is frequency modulation, the modulated waveform. Next, this is the derivation part. After the derivation part, it is of two types. What is the first type? You will learn more about this one in the practical session. Next generation of frequency modulation is, one is reactance tube method. First one, 13.8.1. Another one is transistor reactance modulation. Using transistor we have, that is transistor reactance modulation. The maximum you will get modulation question only in the exam. Next we have one more. Comparison of AM and FM signal. This is modulated signal. First one is, we have modulated signal. AM output. AM output ఎట్లా వస్తుందమ్మా? వచ్చి ఇందులో క్యారియర్ వేవ్ ఉంటుంది. This is AM output. Now what is FM output? How is FM output? the frequencies varies. అంటే స్టార్టింగ్ లో ఒక సిగ్నల్ వస్తుంది, వెరీ నియరెస్ట్ సిగ్నల్స్ ఉంటాయి, మళ్ళీ ఒక ఫార్ అవేకి వెళ్ళిపోతుంది, మళ్ళీ ఇక్కడ నియరెస్ట్ సిగ్నల్స్ వస్తాయి. దిస్ ఈస్ frequency modulation output. Next we have comparison of AM and FM signals. This is also we can expect one short question. Comparison of AM signals and FM signals can be expected one of the short question. Now we will see how this one is changing. What happens noise? 3 subheadings we have a total here. 3 subheadings we will discuss in both the cases. What happens to the AMs? What happens in FM signal? First subheading, what is the first subheading we have? First subheading is amplitude modulation. In amplitude modulation, what happens to the noise? See, so the noise is more across the receiver side and we are getting some amount of distortion across the output. Here the point is mentioned here. There is some across the noise. Manaki noise anedi amplitude modulation, how it is? The same noise anedi, suppose if we are using frequency modulation, ela untundi. 2 ways we have to check. Amplitude modulation as well as in the frequency modulation, how it is changing. So first one is noise. Noise. There is a more noise across the receiver. Some we are getting distortions. I come to the frequency modulation and what are the points mentioned in frequency modulation? Across the receiver, we have less noise comparing to AM. So AM lo manak noise ekkuntundi, FM lo noise is reducing. And next second point, modulation index. Over modulation వల్ల సిగ్నల్స్ అనేది డిస్టార్షన్ అవుతుంది. Because of over modulation, signals are distorting and modulation index have maximum value unity for less distortion. So disturbance, suppose in the signals if I am getting disturbance, at that time modulation index is greater than 1. Distortion ante disturbance ekku untayi. If less disturbance, at that time modulation index is equal to unity. This is about modulation index. Then what about modulation index in this one? In this, no restriction is placed for the modulation index. Frequency of the deviation. Frequency deviation is directly proportional to the magnitude of the signals. Maximum here, no need to bother about the modulation signal because we are using మనం amplitude modulation లోనేమో modulation index అంటాము, ఫ్రీక్వెన్సీకి వచ్చే వరకు ఫ్రీక్వెన్సీ డిస్టార్షన్ అంటామన్నమాట. సో దిస్ ఫ్రీక్వెన్సీ డిస్టార్షన్ is directly proportional to the message signal. This frequency distortion is directly proportional to the message signal. Next, the third point. What is the third point we have? What about power status? Here, power of the modulated signal is greater than power of modulated signal is greater than power of the carrier signal. What about here? Power of the modulated frequency of the modulated signal is equal to same power of the modulated signal is equal to power of the carrier signal. Just this is one of the important short question. We will see once again just the features. What are the points we can cover in this? What is the first point? First point is 3 points we have in this. First point is noise. Second point is modulation index. Third point is power. 3 things we have. First one is noise. One side I am discussing AM. Other side I am writing FM. FM, AM. What are the 3 features we are discussing? First one is noise. Second one is modulation index. Third one is average power. Third one is average power. Here noise is more. Here noise is more. Here noise is less. If you are getting more distortion, at that time modulation index is greater than 1. For the less distortion, modulation index is equal to 1. What here to discuss? Power frequency deviation is directly proportional to the message. frequency distortion is directly proportional with the modulation index, means no restriction for the in the frequency modulation, no restriction. Next, power of the modulated signal. Power of the modulated signal is equal to the carrier signal. Here, power of the modulated signal is equal to the power of the carrier signal, whereas in this, the power of the modulated signal, PM, is much greater than the carrier signal. So these 3 points you have to mention for AM and FM. Then you will get 5 marks easily by learning this table. This is the comparison of AM and FM. Okay, we will discuss one more important question. At least I will cover in short form. The previous year repeated question, demodulation of FM signal. What is demodulation of FM signal? I have transmitter, I have transformer like this. To this transformer, I connected one diode. This diode acts as a rectifier. And again, I am connecting one capacitor. Again, I am connecting one resistor. We draw once again this diagram. What is the diagram? One diode. Across the diode, two capacitors we have. Across the diode, two capacitors. Page number 137. Page number 137. Important previous year asked question. Page number 137. Page 10 marks question asked previous years. We have one diode. Across the diode, two resistors are connected, two capacitors are connected. Across the output, one resistor is connected. To this circuit, I connected to transformer. Primary transformer at a step up, step down. Primary and secondary winding ఉంటుంది. This one I give it. Now, what is the final output? We have to discuss this one. After describing the diagram, what is this topic is slope detector. What is the name of the topic? Name of the topic is slope detector. Slope detector. How you will get output? Means where the frequency is maximum, where the frequency is minimum, like this we will discuss. Across different frequencies, we will see this one. Across the lower frequency, across the higher frequency, what happening to the output? Not this image exactly. Like output waveform, this is this is voltage versus time period. Voltage versus time period. Here you have maximum at resonant frequency. Here across the resonant frequency, the voltage is maximum. Suppose I will take one reference point. I will take the less than this reference point, frequency is decreasing. Frequency is decreasing. Suppose I will take this as a reference point. Here the frequency is increasing. Frequency is decreasing. Wherever the frequency is maximum, across the time period, I will call this as a resonant frequency. So this is the topic called as slope detector. I will recall as it is important. Just I will give once again how to learn this diagram. Connect one diode. Across the diode, take two capacitors. Across the output, connect one resistor. Here, connect one transformer. Connect one transformer. This is for demodulation. This is not for modulation. This is for what? Demodulation of your signal. So, your input here, whatever you have, your input is modulated signal. Input A signal undamma manaki. Whatever the input signal we have, that signal is modulated signal. Whatever the input signal we have is modulated signal. I am applying modulated signal to get the demodulated output. So, here, after drawing the diagram, what you do? Take one peaked sine wave. Peaked sine wave. and say that here the frequency is maximum and this is called as a resonant frequency. Which frequency? Resonant frequency. Take one reference point. The reference point ki down untademo, frequency is decreasing. Here the frequency is increasing. So learn this one. This is very important topic.